Bismillahirrahmanirrahim. I think this is where we stopped last time, right? We went through the manipulation of columns, and today inshallah we'll continue manipulation of rows, and then we will start the first part of the visualization session. So the visualization session will take 2 lectures. Today inshallah we'll cover line and scatter plots, and then the rest will be inshallah in the next lecture. Manipulating rows, I think we went through this quickly before. We can sort the columns, we can sort the rows, okay, given a column, descending or in ascending order. We can also select some of the rows by indices by the method take, and we can also select some rows by the condition using the where statement. And we saw before how to select rows by specific value for the column. So let's go through some quick exercises with that. Before this, let me introduce you to one of the nice concepts here. We saw before that we can define an array using make array. Right? So here we have an array of 4 elements. Now remember that we can do some operations with arrays, right? We can add a number, which means that adding a number to each element in the array. Now look at this. We are comparing the array with a number. Okay? So that's like a logical operation here. And again, it will be done with every element, which means that the result will be an array. Each element will be of the type what here? No, we are comparing, right? It will be Boolean. Yes, it will be Boolean. Okay, so the output here will be an array of Boolean values. So what do you expect of the array now? Of the output?
1, 1, 1.
Okay, so it's not 1, it's 2. Okay, the first one is not 2, right? False. Okay, so false, 2, 2, 2. That's the output of the array, of the operation. Okay, is that clear? So this is similar to multiplying by a number or adding a number, whatever, but this is the logical operation. So the output of the logical operation is logical, which is Boolean here. I can now, with the output array, I can count the non-zero values. Here I want to know actually how many of them are true. Okay, so there are 2 ways to do that. I can count the non-zero, okay, because the false here is represented by a 0. So if I counted the non-zeros, then I know how many of them are true. So that's the first method. The second one is to sum, okay, and the assumption here is that the 2 values are 1s. Okay, so if I sum over the 1s, I will get 3. So these are 2 ways to count the number of 2s in an array of Boolean values. Okay, how is that related to manipulation of rows? We will know very soon. So let's now go through the actual demo. We will use a very nice survey. It was done on a student registered in a class. They were asked some questions, but some not untraditional questions, like whether you are left-handed or right-handed. The extroversion here means how social you are, okay, on a scale. Okay, so 7 maybe or 8 or 9 means you are very social. Okay, hours of sleep on average. And this is nice. Pant leg. Can you guess what does that mean? Okay, so if you wear a pant, which leg goes first? Okay, so some said left leg, and some said right, some said I don't know, maybe both, and so on. And sleep position, okay, on your back, on your right side, on your left side, and so on. Okay, so this is a table of a survey of class students. Now, what we will do with that, we want to answer this question. On average, how long do side sleepers sleep? So those who have side sleeping, how long do they sleep? So how can we do that? We do it on 2 steps, right? First, we select those who are slight sleepers, and then we take the average of their hours of sleep. Okay, now remember where? We used where with a column and a value, and we said that this is just one way of using where. Here is another way. We use to use general condition, we use the type R dot, and then we give the function that we want to use. Okay, so here we want to use a substring matching. Containing is a substring matching. Okay, it will give us all the rows. It will match the rows, actually the values of that column, which is sleep position, that has the word side. Okay, that has side. Okay, because those are the students who said that I'm left-sided, or I sleep on my left side or right side. So whenever the word side appears, that means that he is or she is a side sleeper. Now we got the columns from that, the rows, sorry, from that table. Now we can use numpy.average to average the values. But remember, numpy deals with tables? No, they deal with arrays. Okay, so we have to get the array first that we want to get the average for, which is using the column method. So we use the column method. Now, column of hours of sleep, this is the array of all the values in hours of sleep, and then we average it to get the average value, which is 7.02 here. Okay, is that clear? Now, another question that we want to answer, how many students get at least 8 hours of sleep each night on average? There are multiple ways of doing that. So we want here to get all the students who have 8 or more, right? At least 8 means 8 or more. So the first way is to use the specific function, conditioning function, which is above or equal. So with R, you will see equal to, above or equal to, between, less than. So all kind of comparisons that you want, you will see it in the R function. And I think we discussed last time how to get the documentation of this, right? Which function we use? Help. Okay. It's very intuitive. Okay, help will give us the documentation for the function. So you can say help R, and you will get all the possible functions, and you will see there all the functions that you have in mind. Also the negation of them. So there is not equal to, there is not between, or not less than, or whatever. Okay. So here we want to get all the rows, and then we can use number of rows to get how many students with this condition. Okay, remember number of rows, rows here is for a table. Okay, so we use it with a table to get the number of rows in that table. So in this case, we have 330 students who are. Sorry? Because we want to get the number of students. How many students? So without it, what will happen without this?
Just will give us
the table. Remember, the where will give us a table, right? Table with the new row, with the specific rows. Now we want to know how many rows in that table using num rows. Another way is using what we just discussed earlier. We want to know how many of them have hours of sleep greater than or equal to 8. So we'll compare the array of these values with 8, like this. Okay. This will give us an array of Boolean values, and then we count how many of them are true, like what we did earlier, to get the number of students. Okay. We can also use here sum, right? The same thing like what we did earlier. Yes. Sorry? What is the idea? So we want to get the students who have 8 or more hours of sleep, right? So we want to select from the table the rows for those students. So one way is to use the conditioning, the where statement. This one will select whatever rows we need. And that's another way, is to compare with the number that we want to compare with. Okay, so we use greater than or equal to 8 here. So this one, after we, here. Okay, so forget about this one. So this welcome.column hours of sleep, this is the array of values in that column. We compare it with 8. This will give us an array of Boolean values for each element, whether it's true or false, based on that condition. Now what is remaining is to count the true values of them. Okay. Any other questions? These are two things that I think we did before, just selecting some of the columns and changing the labels of them. So nothing new here. Just selecting and dropping. So this is, you know that if I want to select columns, there are two ways. Either use select with the specific columns that I want to select to keep, or drop the other columns, which means that I will keep the other ones. So nothing new here in terms of manipulation of rows. Any questions? Okay. Okay, so this is the new session. As we said, we have two parts. The first one is about line and scatter plots. So before we go through that, let me introduce the types of attributes. I think you heard the word attribute before. So what is an attribute? This is the thing that we measure for each individual. Okay, like in the previous example, the hours of sleep. Okay, so that's an attribute for each student. Sometimes, by the way, we call attributes variables. That's not the variables in programming, but the variables here, each column, each attribute is called a variable because it has different values for different individuals. Okay, so whether we call it attributes or variables, these are the same thing. Sometimes also we call them features. Okay, so features, attributes, variables, all of these are the same thing. Now, what are the types of attributes? We have two general types of attributes. First, before we say the types, all values should be, all values in a column or for an attribute should be of the same type. And also they should be comparable to each other across all the individuals. Now we have two types. The first one is numerical, when the value in the attribute is on a numerical scale. Can you give me examples of that?
Hours of sleep.
Like hours of sleep. Any other examples?
The age, maybe.
Age, right? In the other group, I got an example in 1 second. GPA is an example of a numeric attribute. Of course, numerical attributes are ordered. You can order them, okay, on a numeric scale. Okay, if when we talk about categorical, we'll see that the other type, we see that they are not ordered. So that's a big difference between the two types. And differences between the values are meaningful. So if I take the difference between the age of the first student, the age of the second student, that has a meaning. Okay, or the difference in GPA and so on. The other type is categorical, when the value comes from a specific list of values, okay, or inventory of values. Can you give me an example of that? So they are not numeric, they are specific values.
Colors.
They are colors. Okay, so the color attribute has specific values, right? What else?
Young, youth, and adult.
Oh yes, youth or adult. Yes, that's another attribute. Day of the week, right? Is also a categorical attribute. So may or may not have an ordering, and that's important. Usually, the categorical attribute doesn't have an order, like the color. There's no order between the colors, right? But sometimes the categorical attribute might have an order. Like what? Days of the week. Right? So we can order the days of the week. Okay? Maybe months also, we can order them. So it's not always the case that categorical attributes don't have order, but most of the cases like that. But for sure, we cannot make any mathematical operations, right? Arithmetical operations on them, since these are not numeric. We cannot say that the difference between two colors is like that, unless we represent them in numerical values. Okay, like RGB, for example. Maybe you can now compute differences between the colors. Questions? Noah, questions? Okay, now we'll get into some detail about each attribute. Actually, we will focus this lecture, this part of the session, the first part of the session, on numerical attributes. And then, inshallah, next time we'll talk more about categorical attributes. The numerical attributes, these are not called numeric just because the values are numeric. Okay, so just because the values are numeric doesn't mean that the variable is numerical. Sometimes it is a categorical attribute, but we give them numbers. So don't be fooled by the fact that the values are numeric. Okay, sometimes even if the values are numeric, but this is not a numerical attribute. They are numeric for another reason. We'll actually discuss an example of that today, inshallah. Okay? When we talk about the census example, you will see that one attribute, which is the gender, has values 0, 1, 2. But those actually are not numeric. They are not meaningful in terms of numbers. They have specific meaning. So of course it doesn't make sense to perform arithmetic on these numbers. We cannot take the difference or the average and so on. Although they are numbers, but this variable is still categorical, even though the numbers were used for the categories. Now let's go through a very nice data set, which is the census data set. So the census data set is a data set that is collecting the populations of the US over years. Okay? So this is done every 10 years. A specific institute there counts how many people are there, and also sometimes give estimations between the years. They estimate how the population will be, and thus we can compare the population over years. Here's a description of the table that we will play with. The first column is called gender, and the gender has, as we saw earlier, it has actually 3 values. 1 for males, 2 for females, and as we will see also there is 0, we'll talk about it now. So 0 means the total of them. Okay, so this table doesn't only give the population in terms of males and females, it also adds rows for totals, okay, for a specific year. So for a specific year, you will see this is the population of males, this is the population of females, and that's also the total. So when for the rows of the totals, the gender is 0, and that's why we have these 3 categories. Why we didn't say male, females, total? Instead of 0, 1, 2.
0, 1, 2 is easier to code.
It's easier to store, so it's more efficient to store. Okay, whether in memory or on disk, this is easier. But the values themselves are not meaningful. So we could have used 3, 4, 5. Doesn't matter, as long as we know that 3 means males and 4 means females and so on. But of course, 0, 1, 2 is more efficient in terms of storage.
So they are categorical.
Sorry?
They are categorical, numerical.
What do you think? So the gender is categorical or numerical in this case? Categorical. Yes. Whenever you are confused, ask yourself, if we take the difference between the values, does that have any meaning? In this case, of course, it doesn't have any meaning, so it's not numerical. There's also another column called age. Of course, age is clear. When age is 0, you'll see that in the table. When age is 0, that means that all boys or girls who are less than 1, okay, between 0 and 1. Age is 10, between 10 and 11. They didn't get beyond 10. But not all of them between the previous age and that age. But there is a special value for the age, which is 999, which is also for the total. Okay, so we have all ages started from 0, actually up to 100, and then you will see a value 999, that's the total of all of them. Okay. And also 100 is a special case because it means 100 or above. So all of people who are 100 or above are categorized in one row instead of being individuals. Okay. So that's a description of the most of the columns here. And we mentioned that numeric codes are often used for storage efficiency. And the values in the column, especially specifically for the age column, they have the same type but are not necessarily comparable always, because we cannot compare 12 with 999. We can compare 12 with 60 or 70, but the special value here, 999, is not comparable. It could be 1000, it could be anything. It's just special value that is not there before, is not used before, to indicate that this is the total. It could be -1. Is that clear? Okay. So did you understand the special value 2 for gender? That's for total, right? Sorry, 0 for gender is for total, right? It's the same thing for age, but instead of using 0, we cannot use 0 because there is 0 age. We can use another value, which is 999. So now let's look into the data. There are really interesting features in the data. And the textbook went through so many really nice features. So please go through them, and we'll go through some of them today together. So let's upload first the data. So here is the data. You'll see so many columns here, gender and age, as we discussed. We also have the population in 2010, 2011, 12, and so on. So that's everything. We will make it a bit simpler. We will only focus on 2010 and 2014. And we will make it even simpler by just relabeling these columns to be 2010 and 2014 directly. So this is the data set now we will work on, and we will just sort it by age. Okay, so that's the starting point now. So our data set now has 4 columns: gender, age, 2010, and 2014, and you know the meaning of each. Questions? Any questions? Now let's play with it. And the first thing, we want to get rid of the total rows. Okay, so we will select all the rows that are below 999. Okay, so we are not interested in these rows. We just need the individual ages. So we'll remove all the rows that are 999, and we also we'll also drop the gender. Okay, so now we don't care about the gender, but not only that, we did something before that. What is this? So what are we doing here? So what is the meaning of gender 0? That's the total. Okay, so what we are interested in here is the total population. We don't want to look at males versus females at that point. We just want to look at age and the total population. Okay? And since we are not interested in gender, we'll just remove it. Remove that column. So here is now the table that we will look at. Yes? Yes, because once we set 0, everything under gender will be 0, right? So all the rows here will have 0 gender. So we'll just remove it from the view. We'll just focus on the other columns because all the value for that column is the same.
Why did we put them all at 0 in the first place?
No, they were not 0 originally. Originally they were 0 and 1 and 2, but when we
Why did we assign them to 0?
no, we didn't assign 0. We actually selected the rows that are zeros. Here, right? With this, it will select only the rows where the gender is 0. Okay, which means that these are the rows that will give us the total. And since now all the rows have zeros in the gender, then we remove that column. Okay. Now let's plot age versus 2010. So that will show us in 2010 what was the population for each age. Okay? And I think we saw the method plot before. So it will give us something like a curve. So this is what we get. That's the plotting age versus 2010. First, this kind of plots is called line plots. Line plot. Okay? And this is because every point is linked to the previous one. So it's like a continuous, or trying to get a continuous curve here. And this works only for numerical values. We are plotting two variables here, right? Or two attributes, age and population. Both of them have to be numeric in order to get a line plot. Now look at the curve and tell me if you notice any observation.
The population,
So it seems,
the population decreased.
okay. Now look at the axes and try to understand what's going on here. The x-axis is the age. It's not time. Okay, so we cannot say the population is decreasing. Okay, the total population I think is increasing over years, but that's not what we are. We are actually looking at populations in 2010 here. So that's all from 1 year. That's population from 1 year, but we are plotting the relationship between age levels and its population. So, for example, people who are at age 40 are like maybe a bit more than 4 million out of the whole population, and so on. Okay, time.
We can say that in 2010 the elderly.
Yes.
We can say that in 2010 the elder people were much less than the other age levels.
What do you expect? What do you expect? Do you expect that? Is that surprising or not?
No, it's not.
That's not surprising, right? We know that most of the population is in the early ages. Okay, and that's true here. You see around 20. These are the youth, like you. Okay, so most of the population is at that age. The nice thing is that also around 40, which is like me, actually it's a bit more than 40. Also is among the popular ages. But so up to like maybe 50, they are not very far from each other, right? So it's kind of balanced. But if you look here, there's something unexpected happened here, right? This sharp drop, okay, between these ages, maybe 63 and 64, something like that. Okay, so let's get into this more deeply. Let's zoom in. How can we do that? We select the ages between maybe between 60 and maybe 70 or something like that. Okay, so these two cells are just giving us ways of putting a title for the plot. So that's not what we want to do here. It's just giving a title for the plot. But now we'll select the ages between 60 and 71. So this is a smaller table now, and we plot them. So now we look into this area more deeply. Now we are only plotting between 60 and 70 or 60 and 71. Actually, between, let me say this, maybe we didn't say it before. The function between, like a range, remember? It includes the first number and exclude the last one. So actually this is between 60 and 70 inclusively. So looking at this now, it is very clear that there is a sharp drop here. Yes, between 63 and 64. Any idea how we can get to guess what happened or what made this, what caused this? Any guesses how we can do that? Yeah, that means that in 2010, so what's the meaning of this? In 2010, people at age 63 are much more than people who are at age 64. That's very strange, right? Why is that? What's special about this age? It seems like there is something special about this age, okay, in this country. Remember, this is in the US. That's not over the world, in the world. That's in that country. In 2010, these two ages, there's something weird about them. So how can we get how can we start to think about something like that? So it seems like there's something happened. Something maybe happened at that time. What time we should look at? Huh? 2010. So what happened in 2010? Maybe there is a disease that came to people who are at 64, selecting people who are at 64. That's not.
Maybe this was the retirement age, so they died from depression.
Maybe, no, but not that big drop, right? Okay, one way of looking into this, to think about, okay, people who are at age 64 now, okay, when were they born? At what year they were born? So that's 2010 minus 64, right? Okay, so 2010 minus 64 will give us 1946. So maybe there is something happened at that year that made the birth rates to decrease a lot, and the effect of that appeared in the difference in the population of that ages. Did you get the idea here? Okay. If let's say that something happened today that will, for some reason, let's not think about how, but for some reason, the birth rate decreased a lot. Maybe there was a disease to pregnant women, and most of them didn't give birth properly at that year. Okay. Now, if I counted the population 10 years from today, those who were just born today, okay, after 20 years they will have of age 20, right? This will be much less than 21 or 19, right? Actually, it will be much less than 19 if the birth rate were again normal, okay? So that effect will appear on those people at that time. So if we know that there is something happened in 1946, that might be a justification or a cause behind this drop. And actually, if you looked at the history of the US, you will find there was a war at that time. Actually, there was the Pearl Harbor attack, and immediately after that there was an intensive war. So of course that might be the cause of the low rate of birth. Okay. Of course, to know that, you might not be aware of the US history, right? So you need a historian working with you to tell you maybe that's the reason.
We can see to the last years.
You can?
We can see to the last year's population.
You mean the other ages?
No, for the same age. For example, the 64 age in 2009, it is in the same rate.
Ah, that's a good point. Yes, yes, but bear with me. Okay, we are only looking at 2010 now. Okay, but at least we have maybe some starting story here. Okay, now we can work with the domain expert and probably we can justify this. Okay?
Okay, I have a question
Yes.
about the method between.
Yes.
The method range is, what do they call it?
It would give us an array, a range.
Okay.
But this one is a condition
How do I know if it's inclusive or not?
by the definition of the function. If you look at the documentation of the function, it will tell you that
Yes, but for ranges, no.
no, it is they are working similarly. They're working similarly. The ending point is not included. Okay? Fine. Now let's plot age only and see what does that mean. So what happened here? Huh? What happened first? What is that plot? Is that line plot? It is a line plot, right? But we are plotting two curves here. 2 years, because the table has 2010 and 2014. Okay. Remember when we used plot with we used to indicate two columns, right? Here we just give age, which means that please plot it with the other columns, with all of the other columns. In that case, we have two, so it plotted it with the two curves. What do you notice here? Just shifted. How many years? 4, right? Because that's 2010, 2014. Just shifted. Of course, of course that makes sense. And the counting is independent. And counting happened in both years, by the way. Okay, counting happened in both years independently, and it turned out that they are shifted. And this is related to what was mentioned earlier about looking at different years, and that also that sharp drop is indicated in both years. Now let's look at males and females. So previously we didn't look into males and females, we looked at the totals only, right? Here is very nice analysis about males and females. I think you would be interested in that. First, let's look at males and let's capture males and females only by selecting the rows for males and rows for females. Okay, and drop the gender column. Now we add them into a table, a new table, with a third column, which is the age. So now we will get something like this: age, males, females. Age, males, females, and that's only for I think 2014. Sorry, 2014. Okay, with me? Now, if we plot age, we'll get something similar to what we just saw. But now, it won't be 2010 and 2014. It will be males and females. So we will see the difference now between the population of males and females. What do you expect without looking at the data? Why? Why females should be more? I didn't expect this answer, actually. Anyway, let's look at what we will get. What do you notice from that? So males are the blue ones, females are the yellow ones. So up to this point, which is what? Which is at age? Which age is that? Like 35? Right? So up to 35, who were more? Males were more than females. Not so much, by the way, right? But then they switched it, and females became more. Right? Not very much? Okay, but there is a difference. There is a noticeable difference here. Okay, now let's do something to look into it in more depth. Look at these commands and tell me what are we doing. So what are we doing in the first one? We are getting the total. Yes, very good. So we are getting the total, and then we are dividing females with the total. This will give us the percentage of females. So if the percentage of females is above what? Above 50, that means they are more than males, and less than 50, that means that they are less. Okay, so these are the numbers. Okay, and let's not look at the numbers now. Let's look at, because it's really hard to look at numbers, and that's the purpose of the session. We want to visualize the numbers so that it will be much easier for us to get insights from the data. So what we will do is to, this is just renaming the column, and then we plot age with percentile, or percent females. Here is the plot. Look at it. Is that what you expected? So we said that the differences are not too much, right? There are differences, and what we expected is that up to 35, that's what we saw in the table, right? Up to 35, males were more, so the percentage is less than 50, okay? But then, what happened? The percentage kept increasing above 50. We know that above 35, age 35, the females were more, right? But did you expect that the ratio comes this way? So here it is 50%. Here is 55. Here is 60, 70, and so on. So that's the ratio between females and males at these ages. Did you expect that? First, what does that mean?
Females more than the males, 80%.
I understand. Females are more than males, which means, what is the meaning of that? They live more. Yes, they live more. Or men live less or die before, much more before women. Okay? At these ages. Okay? But, so that's one. That's one. And how can we know the reason behind that? Any guesses? maybe they work harder. That's why they. I mean. I didn't say who. Yeah, I said maybe working harder. I didn't say men or female. Anyway, we cannot guess from that table, right? Okay, how can we know? Maybe we need to do some social studies here. Okay, maybe we need to do some social studies. But one thing before we stop is not about the reason why. It seems like there is something, right? That a woman is much more at older ages. Okay, that's clear. But with that, the ratios also are a bit surprising. Yeah, the ratios here are not just 50 or 55 or 60. It's increasing exponentially, increasing a lot. Yeah, maybe it would be okay if we saw something like this, increasing like that, up to maybe 55. Still a lot. In 300 million, the percentage, 55% versus 45%, that's a lot. Okay, but that's not over the entire population, and that's the point that I wanted you to think about. Okay? Let's look at these two rows only, 98 and 99. This is for males, and that's for females. Do you notice something about these numbers? And this is 2014, right? So look at these two numbers and these two numbers. If we compare them with the numbers that are at earlier ages, these are very small numbers, right? And that's expected. Very few people live up to that age, right? That's expected. And that might also justify why the ratios are that big, because differences in small numbers make big ratios. If I divided 2 by 3, that's 66%, although the difference is just 1. But if the same difference went to higher numbers, like millions at early ages, then the percentage would be very small. And that will justify why we are getting smaller percentages in the beginning, but with more age, with higher age, the actual numbers are less, and thus the ratios might be bigger. Okay? So you really need to pay a lot of attention to the scale of the numbers and whether this is actually what you want to measure or not. Okay? Any questions? Thank you.